Welcome to this next tutorial on nowRail, the model railway control system, and today I'm going to be showing you the prototype loco controller that I've built. A lot of people have been asking for the code for this, so I thought I'd go through it today, show you sort of how the controller works, how the code is sort of uploaded and built, and some of the issues that I've come across, as well as the next version that is already in the process of being built. So let's have a look at it on the breadboard first. So here is the project. You've got the fully built controller on the right here, and obviously the breadboard version. Sorry if it's looking a little bit dark on the breadboard, but when I turn my lights on it reflects off the screen, so apologies for the shadows. So this is the basic controller. I've designed it primarily for me. I work with DCC-EX, but this will work with an NCE controller through the sort of nowRail interface. So obviously turn the controller on, just press the start button. You've then got the various, obviously the encoder changes the speed. As you can see, if I want to do the various functions, just press the buttons. If I want to get to the higher range of functions, again, not a problem. And yeah, we do a full set of functions. You will notice up here that the controller has the name of the loco as well as the decoder address. Now, when I select change loco, nowRail within the EEPROM system will store 200 locos, their various function details, addresses, and a 20-character name. So I can obviously select any loco I want, and the other thing is, if I want to edit it, I can just sort of change the name as I want and update it. Select the loco, and I now have that loco running. I also have the clock, the layout clock. Now, if I speed the clock up to 2 times, one of the things that immediately happens is this controller over here is also speeded up, because obviously the new clock rate is broadcast over nowRail to any other controller on the system. So let's just put that back to 1. There is also a loco recall system, so that allows me to go back to previous locos. You'll notice it goes yellow. That is when it is being worked on, and once you don't sort of keep flicking through the recall, after a few seconds it'll go, okay, this is now the loco that you have selected, and it will set it up on the controller. So that is the basics of how the controller works at the moment. Now, this version here obviously is without the case, and this is actually a new version that I'm working on. One of the differences on this one is that when I select the loco, I have the ability to set a consist. And the consist, I can basically choose any locos that I want. I can decide if I want them running backwards or forwards. And as soon as this is done and I exit that, that will now run this loco plus all those other locos as a consist. So that is where nowRail is sort of going for the future. Now, one other little bit that I forgot to mention is with the speed controller, at the moment I have this where going clockwise increases the speed, going anti-clockwise decreases the speed. That's just because the way my layout is set up, it's an end-to-end. If I click on the button, it immediately sets the speed to 0. Now, one other feature with this, the stop button does not send out an emergency stop signal. Instead, with DCC-EX, it actually cuts the power completely. Now, the reason I did this rather than sending an emergency stop command, which DCC-EX will handle is I've had very odd occasions with certain makes of decoders where suddenly I've had a loco just run away and go completely bonkers. By turning the power off, I know that that loco is going to stop regardless of how mad the if you like, the chip has gone. So that is why it works the way it does. So when it comes down to the components, obviously we've got the touch screen. Down here there is the EEPROM, there is a 10k resistor, ESP32 dev module, and a rotary encoder. That are the only components that you require if you wish to have, if you like, a tethered version. Obviously, if you want it to be hands-free, you know, no cables, then you are going to need a battery, and within this one, that is exactly what I have up here. There is a battery. One warning about using a battery, and it's something that I need to address, and it's why I'm not going to go into the battery system in this tutorial, is that if the battery starts to go flat, if you are not giving enough voltage to the EEPROM, one of the dangers is when you send a write command to the EEPROM, it doesn't write anything and you finish up losing all your loco data. It's just something that I have discovered, so I'm doing a little bit of work for myself to figure out how can I sort of monitor the battery condition, and I might finish up putting a slightly larger battery in there. The case itself that I've made for this, I'll be honest, it's 3D printed, and if people are interested, I'll upload the 3D print files for that as well. Now, as always, there is a link to the Digital Down website, to the nowRail page. If you go over to that page, scroll yourself down through the page until you come to the touchscreen loco controller. Now, the touchscreen loco controller, the way I've built it, it uses a lot of the loco controller functions that are built into nowRail. In fact, I'll be honest, I developed a lot of these functions by building the controller, because you only find out what's needed when you build something. So clicking on this link takes you down to the main project section. To build this, obviously, you need certain components. There are two external libraries that are required. There is TFT_ESPI by Bodmer. He's a guy who builds this library. He does libraries for touchscreens, and to be honest, is a genius. And all my thanks to him for the work that he has done on that. One of the oddities about this project is I didn't use the, if you like, the touch system for that library. I actually used a different library, the FT6236 library. Now, when you download the project file, which is down here, it will actually have this library within it, as well as obviously all of the code for the project. Now, with the connections, with the EEPROM, there is a section in nowRail that deals with the EEPROM and gives you the complete circuit diagram. I've put a little red mark on the chip. There is a little dimple in one end of the chip, so just make sure you get the chip the right way round, and you will require this 10k resistor. So that is how the EEPROM is set up. And if you're on the EEPROM section on the nowRail page, just above that are the loco controller functions, and these are basic functions you can call to get loco addresses if you're writing your own custom code. Obviously, I've built this as a prototype. I've built what I want to build, but if you wanted to build your own controller, all the features are there for you to call on if you need them. Now, the next thing, obviously, I've got the rotary encoder. On a rotary encoder module, there are basically 5 pins. There is a switch which in my controller goes to pin 25 on the ESP32. I am using the ESP32 dev module for this project. That is what it has been built and tested on. Obviously you can change the code and try and make it on something else, but I haven't tested it anywhere else, so it's built for this particular module. The encoder left goes to the ESP32 pin 26 and encoder right is pin 27. Now what I tend to say to you is put it on your breadboard, give it a test, and if you've got it, if it's going the wrong way for you, switch the connections over. When it comes to the LCD touchscreen, these are the connections for the ILI 9488 and the 9486 with the FT6236 touch system. Now the FT6236 is a capacitive touch switch rather than the touch screens where you sort of use a pencil probe. So this works in exactly the same way as your mobile phone screen works. The reason I've used these, they are a touch more expensive. I think the screens are about 10 or 11 pounds. I'll have a quick check in a minute, but the screens are brighter with the capacitive system, and also obviously you don't need to have some kind of pencil and start putting pressure on. So I have put the connections for the screen and obviously for the ESP32. Something to be aware of, there are 3 pins that do not get connected. Now I have done tutorials on the 9486 and the 9488. One of the issues when you buy these screens, and you know, I buy them off AliExpress, let's be honest, I get them cheap. Sometimes I think the supplier doesn't even know which screen he's sending. So you can get a 9488 instead of a 9486 or vice versa. What you will tend to find is that when you get the wrong screen, if you go onto these links, there are some things about the screens, and what you will tend to do is get the wrong background colors. If you set up a 9488 board and you've got as a 9486, instead of getting white, I tend to get a greeny color, and again here that background's supposed to be red. So again, what I have done is there are some configuration files for these different screens, and again they are in the project file that you can download, so you don't have to worry about working out the setup for yourself. So going over to the AliExpress website, I have typed in ILI 9488 FT6236, and this is the sort of thing that comes up. The screens you're looking for should be 320 by 480, and yep, that looks the business to me. Obviously you could also use the 9486. Let's just do a quick search for that one, and again you've got a variety of these coming up. That's about it. That's all there is to these things. As you can see though, you're looking at about £10 for your screen. So to build the whole project realistically with the chip, the EEPROM, the rotary encoder, you know, we're looking at £15–16 probably tops for all the components. So let's start to look at the coding of this. Now this is nowRail 1.1.0, which is the current sort of release version, and you'll notice within it you have the 5 tabs. Now I'm just going to move this out the way, and we now have the version that I have set to download. One of the first things you may notice with this is it is using nowRail 0.9.0. Now you can switch this and basically move these extra tabs that I've put in into the latest version. It works absolutely fine. the reason I have put this version up here is I do like to test things thoroughly, and this is the version that is running on my hand controller, and that controller has run for 8 hours non-stop at an exhibition, running the layout without any problems. So if you like, I'm pretty confident that the code works well on this. Now you will notice that obviously I have some extra tabs. One of them is a set of fonts. This is just for the touch screen. I've then set another tab up for the various functions that I use to build the screen. Now, I am not going to give a tutorial today on how I have made this work. That is, I'll be honest, it's quite complicated. Some of the code, again, we've got another sort of tab that is to do with the touch system, and if people want some lessons on how to build touchscreen controller systems, I'm quite happy to do some separate tutorials, but trying to explain that in one lesson today would make this a very, very long video. So going over to the main screen, obviously it starts as a normal nowRail setup would. The things that have then been added are these two libraries, so make sure you have installed these libraries. This library, the Bodmer one tft_esp.h, that is the library for the, if you like, the display part of the screen, and that is available if you go into your libraries. It is actually downloadable straight away. At the time of doing this video, I didn't seem to be able to find this particular library as downloadable through the IDE, hence the reason I have put it in the project folder. Obviously, you don't have to worry too much about this code if you're just going to download it and install it, but if you want to build your own projects, it's not a bad idea to sort of see how this works. So on the setup, obviously I've got the standard nowRail setup, and I set the clock to 1, so the speed starts at normal time, but then you'll notice I've added these other functions that call functions within encoder, screen and touch. And then obviously on the main loop, I have got the main nowRail control system, and then I've got my other functions that get called on every iteration of the loop to drive touch, the encoder and the button press. And the button press obviously is when you press down on the encoder button. Now, what I'm just going to show you is one little issue that can happen when you upload the file to your project. Now, I'm not going to upload to my finished hand controller, so this is going to that breadboard version, and the first thing you might notice is it is using nowRail 1.2.0. It is not available because it's still in test mode. However, it still shows one of the issues. So if I click the compile button, if you watch the screen, sorry if it takes a little bit of time. One of the problems with this project, it is now a big project, and for those of you that are new to the ESP32, due to all the number of libraries, the first time that you compile your code on the IDE, it does tend to take a little bit of time. So hopefully we're going to get there. I just want you to see an error that, or something that looks like an error. There we go. There is a warning that appears and it says touch CS pin not defined. Now this is a warning from the TFT_ESPI library. Hang on, it's all uploading now. Let's just let that finish. There we go, that's all uploaded. Let's go back to the output. I'm just going to scroll up to that red warning. So you will see this warning come up, but it is a warning, it is not a bug, and it's literally because I haven't used one of the features within the library. And the guy who wrote the library quite wisely said, hey guys, you haven't connected the touch system. Obviously in the code that I am using, the let's get the right page, the FT6236 library is taking care of the touch system. So if you see that red warning, don't panic, it's fine, and eventually, as you can see, it will compile and upload. Now, when it has uploaded, I'm just going to go through, if you like, the log of what it has done. Once it has uploaded, one of the first things you'll start to see is a load of numbers appear in the serial monitor. This is as it's just checking the EEPROM. It's reading from the EEPROM. If it is the first time that you've uploaded this to your board and the EEPROM is brand new, the startup time, it can actually take a couple of minutes because it actually has to write a whole load of information to set the EEPROM up ready for you to store your data. If it doesn't sort of write some things to the EEPROM, it can get quite interesting because it can try to then write characters that don't exist. Now, once everything is done, if I just bring in the camera, if you've got the diagnostics turned on, as you then start to do your various items, you can see because I've got a consist running, it's sending out instructions to a number of locos at the same time. If I then go to change loco and set consist, I'm going to clear the consist. There's a single button to clear everything. Now when I move the rotary encoder, it's now only sending instructions to the single loco. And again, going back to the main screen, you can see the various functions that get sent to DCC-EX. So that's a project that is working well. Now, going back to my finished version, down here I have a USB-C connector. I'll be honest, on my layout there are panels along the front of the layout that allow me to plug in USB-C connectors. They're nice and small, so they fitted nicely into the case. Obviously I have a battery, which in turn means that I have to have a power switch. You've got obviously the back of the rotary encoder, you can see the back of the screen, and I mount the ESP-32 on a set of headers on a piece of Vera board, and you can see I use these sort of oh, what do they call them? I forget the name of the plugs now, but I use these sort of plugs because they don't tend to shake loose. Now, I still can't remember the name of those plugs. They're the ones that you have to use the crimps on. But anyway, I've removed the ESP-32 from its sockets just to show you what lies underneath. So here obviously is the EEPROM. I've got it in a socket. Here is a DC to DC step-up boost converter module, and this boosts from 3.7 volts to 5 volts. Now that is because the LiPo battery is putting out 3.7 volts, but I'm using the VIN pin on the ESP-32 and I like to supply it with 5 volts. So this little unit provides the boost. Going over to my screen, just going on to eBay, these are the sort of units that I'm using, and it just helps with keeping the power at the level I want. Obviously, if you're just going to use a USB connection or a wired connection, you don't need to worry about these. Now, going back to the project, one other little thing I did, It's a little bit difficult to view it on the camera, but you see there's a mark here. That is some red nail varnish. Yes, I use this sort of stuff all the time, and the reason I've marked that particular area of the board was to make sure that when I put the ESP32 back in, I match up the 3.3 volts with that red mark. That way there's no chance of me putting the board in back to front, because if you're new to the ESP32, they are a lot more delicate than dealing with your Arduino Uno, and do not take well to short circuits, over voltages or anything else. They just stop working. So that is the sort of prototype nowRail controller, and it works particularly well with DCC-EX. Again, it works with my NCE system, so you know I can use it with either, which is a really nice thing. I will continue to work on the next version. The good thing about the next version that I'm working on, it's exactly the same components, so same screen, same encoders. You're not going to have to start fitting extra hardware. So if you build it for this software, the next software will work. So I think that's everything with the current controller. I hope that's been useful to you, and especially for people like me who use DCC-EX. This controller has been a really nice feature. One of the things I'm hoping to add in the next version is the ability to send loco details from one controller to the other. I'm working on that as a new feature. So I think that's everything, and any questions, please either email me off the Digital Town website or drop a comment in the comments section below the video, and please click the like and subscribe because it really does help the channel. I think that's everything for now. I'll see you in the next video. Bye for now.